Hello everyone, my name is Muhammad Jibril and in this video I will present my Basic Network Sniffer project which I developed as part of my CodeAlpha Cyber Security Internship. This project was built using Python and the Scapy library. The main idea behind this project is to capture live network packets and display useful information about them. It is a simple tool that helps us understand how devices communicate over a network and how different network protocols work. Before we start, let's see what this tool does. The program first displays all available network interfaces of the machine. After selecting an interface, it starts listening for live network traffic and the capture packet in real time. For each captured packet, this tool displays important information including the capture time, the packet type such as TCP, UTP, or RCMP, source and destination IP address, source destination MAC address, source and destination port number, the related network service such as HTTP or HTTPS, the packet size, and the packet period if it is available. To make the output easier to read, I use the colored ticket in the terminal. Now let's take a quick look at the code. First, I imported the required libraries. I use the Scapy to capture and analyze network packets. I also imported the socket module to identify common service based on port number and the data time module to display the capture time. I use the coloring to display colored output in the terminal, making the information easier to read. I also imported the time module to add a small delay between packets so the output is easier to follow. Finally, I imported the show banner function to display the project banner as the project start. I also initialize the coloring using the image with the auto reset set to true. So the terminal colors are automatically set after each print statement. Next, I create a function called getServe. This function receives the source and destination ports and tries to identify the network of service. For example, if the port is ET, it contains HTTP, and if it's core 43, it contains HTTPS. If the service cannot be identified, the function returns unknown. The main function in this project is called Analyzer. This function is responsible for analyzing every packet captured by the tool. Whenever a new packet is detected, Scapy automatically sets it to the analyzer function. The function first records the current date and time, so every captured packet is displayed with its capture timestamp. Then it checks whether the packet contains an IP layer. If it doesn't, the packet is ignored because it doesn't contain the information we need. If an IP layer is found, the function extracts useful information such as the source and destination IP address, the MAC address, and the packet size. Next, it checks the packet protocol. If the packet use TCP, UDP, or RCMP, the tool displays the protocol-specific information. For TCP and UDP packets, it also displays the source and destination port numbers. After that, the function tries to identify the network service based on the port number. For example, it can recognize service like HTTP, HTTPS, or DNS. If the packet contains a link, the tool displays it as well. Finally, all the collected information is printed in a clear and organized format, making it easier to analyze the captured network traffic. Here I use the datetime module to record the current date and time. So every captured packet is displayed with its capture timestamp. Finally, I use a sniffer or the Scapy library to capture network packets. Before starting the packet capture, the program first displays all available network interface on the machine. The user can then use the interface that will be monitored. To make the input more reliable, I added input validation to make sure the user enters a valid interface number. The program also provides an exit option by entering 99. After a valid interface is selected, the tool creates an sniffer object. I configured it with the main parameters I face, which are specific the selected network interface (BRN), which tells Scapy to send every capture packet to the analyzer function for processing and store equal false, which prevent Scapy from storing all captured packet in memory, helping reduce memory use. Since this tool only analyzes and displays packets, there is no need to keep them in memory. This makes the tool more efficient, especially when capturing network traffic for a long time. After creating the snapper, I start it by calling the start method. Unlike the normal snip function, a sniffer works in the background. The normal snip function blocks the program. This means that once it starts capturing packet, the program cannot execute the next lines of code until packet capturing stops. On the other hand, a sniffer runs in a separate background thread. This allows the main program to continue running while packets are being captured at the same time. Because of that, the tool can keep responding to the user and it can be stopped safely by pressing and parsing Control C. After starting the snake, I used the infinite while loop with time sleep one. The purpose of this loop is simple to keep the main program running while a sniffer contains the capturing packet in the background. The sleep function also prevents the loop from consuming unnecessary CPU resources. Finally, I handled the keyboard interrupt exhibition. When the program when the user presses Ctrl C, the program does not close immediately. Instead, it first stores the bucket capture by calling a snip to stop information message and then exits the application successfully. This ensures that the program shuts down properly without leaving the snip while running. You can snip off the snip as a function that keeps the program busy capturing packets, while a sync sniffer capture packets in the background, allowing the reset of the program to continue running normally. Now let's run the tool. As you can see, the program starts successfully and displays the available network interfaces. After selecting an interface, it, begin, it begins capturing live network traffic. Whenever a packet is detected, the tool analyzes it and displays all the available information for HTTP traffic. It may also display the packet fields if it is available. This makes it easier to observe network communication and understand what is happening on the network. This project is a basic implementation that was developed to meet the internship requirements. In the future, I plan to improve it by adding more features such as packet filtering, saving captured packets to long files, and adding more advanced network in its future. Thank you for watching.